All right, well, I'll just, okay. So I'm going to be talking about building a local Beowulf cluster. I will be addressing Rex later, but first I want to lay down some fundamentals about what a Beowulf cluster is and what goes into building one. You may recall the old slash dot joke whenever a new device or something comes out. Even going back 20 years, it was, hey, let's build a Beowulf cluster out of them.
Imagine a Beowulf cluster of these. I believe that was the exact meme tagline that they kept saying.
Interestingly, another JPL connection, the man who invented the Beowulf cluster, Thomas Sterling, who I actually met through my work at LSU, was at JPL when he invented the Beowulf cluster.
Wow.
And the whole point of it was to just slap together a bunch of commodity PCs running Linux together and use something called MPI or message passing interface or some implementation of it to parallelize scientific codes across a cluster of individual computers by sending messages back and forth. And so what I'm going to be talking about is how to actually build and not just imagine a Beowulf cluster. And then I will show you the Rex script that I used to implement part of it, but not all. I am working on implementing all of the pieces together that you need, software pieces for the Beowulf cluster. And I will show you the cluster in action. So let us begin. Okay, so I use AdSurg. I've talked about it before. I don't know, you may or may not be familiar with my talks on this, but basically it's a coastal ocean model that is parallelized using MPI, and we can run it on you can run it on one CPU, you can run it on your PC, just locally using all of the CPUs, and then parallelize using some implementation of MPI. OpenMPI is the open source and most commonly used version, but compilers like Intel have their own proprietary implementation. I usually run it on university supercomputers at LSU, Louisiana State University, and also at the University of Texas, which is local to where I am at the moment in Austin. And so it's parallelized using OpenMPI, and we can. It's very portable. So this talk is part of a training that I did a few months ago to individuals who are running AdCirc, but we needed to explain to them how to set up their own cluster because not everybody has access to these large machines. But it is getting cheaper, as you can imagine, to build your own clusters. And I will go over some price points and maybe convince you to hit up eBay later on and buy a few PCs to network together and create your own cluster. Or maybe you just have a bunch of old PCs laying around like some of us do, myself included, that you may want to network together and play around with. So that's what the whole point of this is. Now, this is a picture of the very similar to the cluster. Two out of four of those computers are in my home right now running. And the other two were a friend of mine who met me at this training. We put our clusters together and we were actually running, I think my towers there were on the right-hand side. They have 28 cores each, and then his had like 8 each. So obviously my computer was faster, but we got these computers off of eBay individually very cheaply. And it was not difficult or expensive to mostly max out the number of cores that you can get on there. These are Dell 7810s, and you can get, there's 2 sockets, and you can have on each socket 14 cores. And you can get one of those CPUs, a 14-core CPU Xeon, for like $10. Okay. Now, it does support 20 cores per socket, but if you wanted one of those, it's going to cost you like $70 or $80. So clearly it's a lot cheaper just to get 28 cores on there versus the 40. But the point is that they're cheap to acquire and they're very powerful. Okay, and so we're going to go over. I'm going to go over a little bit more about the hardware, talk about the OS, networking, sharing the file system with NFS, and then I'm going to run through. I'll skip through building AdCirc, but I'll still mention some things because it is kind of interesting. And then finally running parallel AdCirc, and then I'll jump over to the stuff about Rex, which is where I talk about actually installing Slurm, which is the it's the batch queue that you can submit jobs to. So these clusters tend to be, at least when they're used by more than one person, they tend to benefit from an arbiter of who can run what when and on how much of the machine. And it's called a batch manager or a queue manager. And all of the university environments have them, and if it's even beneficial if you are the only person using this cluster, but maybe you want to schedule a bunch of runs to run one after the other. Or in my case, I will run a forecast, a storm surge forecasting, automated forecasting framework when there's a hurricane in the either in the Atlantic or the Gulf of Mexico. And if you're interested in learning more about that, go check out the talk from the Perl conference last year on ASGS. That I go through the whole system there. Okay, so when we want to consider hardware, we're looking at budget. Obviously, we're probably, if you're interested in this, you're thinking about running your own cluster and spending your own money. Required time to solution. It's fun and cool to have one of these clusters, even if you don't know what you want to do with them. But it's actually beneficial and may make you some money or allow you to do some things you can get paid for if you have a specific purpose in mind. In my case, it's running this AdCirc program. There are other, ocean models, weather models, and computational fluid dynamic models that you can run. I'm not sure of any applications that are not in the scientific domain that you might want to run on these clusters, but AI might be one of them. I'm not familiar at all in running AI on these clusters, although I suspect that they require some GPUs, which we're not talking about GPUs here. Okay, so this is hard to see, but when I was at this training a few months ago, there were consultants there from civil engineering firms that had laptops with 32 cores in them. Okay, and they were Dell laptops, and I looked up how much they actually cost if I were to buy one, let's say, and they cost $7,500. Okay, now if and that's for 30 cores, and these are not the primary machines that they run their simulations on, but it is they do run some smaller models on there. But it got me thinking. I'm spending one of these machines, these towers that I buy, I can usually find between $150 and $200, and that includes finding the 14-core CPU or at least two of them, and then addressing any other needs it has for about $200, say max $225. And so if I were to apply that $7,500 to a cluster, then I could really do some really cool, like, large scale computations. And what this chart is showing is for what you would spend, and then of course it's different. You're going to use a laptop for portability and some other things rather than just having a huge cluster sitting. You can't take a huge cluster with you, but based on my calculations, you can buy, say, 33 compute nodes with that $7,500. Okay, and what that gives you is based on this chart, you versus say, oh, I have 28 cores for these laptops. You can either get 28 cores on the laptop or you can get 924 cores on a cluster. Okay, just to give you some comparison. Now, what does that look like as far as like computational power? Well, we measure things in teraflops, or floating point operations per second, and a teraflop is like what, 1 billion floating point operations per second. On one of these laptops, you can get about 1.25 teraflops. And on one of these clusters, say that $7,500 would buy you, you're just using old hardware, you can get about 41 teraflops, okay? And so if you want to look at the cost per teraflop, then with a laptop, obviously it's going to be $7,500 or thereabout. And then for the cluster though, it's going to be $180 per teraflop. So the point of all of this is just to show you, if you wanted to run parallel jobs and what is the most cost effective computationally, if your priority was to max out the teraflops or the amount of computational power you have, then you would definitely want to just build your own cluster rather than spend $7,500 on one of these large modern laptops. There was a stat in here. I don't know if it's in here or not, but there is a measure of that computer or universities and institutions that have supercomputers love to get on it. It's this top 500 supercomputing list. And so I had looked to see, if at the time let me think. In the year that these machines, these Dell machines were put out, which I think was 2017, how many of them would you need to build a cluster that would crack that top 500? And I think I've calculated that you would need 88 of them. But in any case, the whole point was to just show you that you can build a very powerful computer, a supercomputer, for relatively little money, especially if you're doing things productive and as part of your business. So the HPC that we put together, or the lab cluster that we put together at this training, as I mentioned, it was a Dell Precision 7810s. They're PC towers. They were used for back office and mid-tier engineering workstations, so like CAD stuff. And each of them, we're assuming it's going to max out at 28 cores per PC. Although I realized later on you can, for a lot more money, relatively speaking, get 40 cores per tower. But that might be justified. It might not be. It hasn't been justified for me yet. Brand new, these machines were $14,000. So they sold them between 2014 and 2021. Now, this isn't really a commercial for the Dell Precision 2810, but it is a commercial for doing your homework and finding out where the drop off for cost per core is. In this case, I actually used ChatGPT to do some research about when was the say back, I just picked a date in 2017, what was the most powerful business tower you could buy, and how with the most amount of cores. And it told, I think 2017 was the date I picked. But in any case, at the time it came out, the result was the Dell 7810. And so I went over to eBay and looked. And at that time, these Dells were actually a little cheaper. I think I put a premium on them because I started buying them and stocking the CPUs. But in any case, they seem to have become a lot more popular recently because they are very cheap and you can really pack in a lot of cores. But the point of that is, it's kind of like a used car to some degree. As soon as computers aren't like, as soon as you drive it off the lot, they tank in value. But we can all attest to the fact that computing equipment drops off in value very quickly. And if you go back 3, 5, 7 years, you can get some extremely powerful computers for dirt cheap. And so that's the class of machines that you want to target if you're interested in building a cluster of your own. You want to maximize the number of cores per dollar. Okay, that's your metric. You're not looking at the megahertz. You're not looking at the amount of memory on the computer. If you're looking at a CPU, a problem that is solvable with a CPU problem over, parallelized over a number of cores, you're going to go on eBay and you're going to find out, okay, what's the, how can I get as many cores as possible for as cheap as possible? And so that's kind of like what this talks about here. Oh, here it is. So I was talking about this top 500. So in 2014, when the machine first came out, if I wanted to crack into the top 500 back then in 2014, I would have had to buy 82 of these things at 28 cores. Okay. And so, I mean, that's not bad. That's not too shabby at all. If we were to do it now, I'd have to probably buy like, I don't know, 1 million of these things and I don't even actually know how they measure the list now with the GPUs and AI. They probably have multiple lists based on the application. Okay, so building steps. So you have a bunch of clustered or a bunch of CPUs and you want to cluster them together. It's just like building your own PC, but just doing it a bunch of times. You have to install an operating system. And in my case, I decided to go with Ubuntu, which is Ubuntu plus XFCE, which is just a lighter weight UI. And really, you don't even need a UI. I mean, you don't need the window manager, but I wanted to have it on there just, for user friendliness. Obviously, these large clusters that run at the universities and other places, they're kept in data centers. They don't have window managers installed, but since this is something that, like right now, mine's literally running in my living room, okay, then you're going to want to be able to just out of ease of administration, pull up a window and do stuff. So what I have done here is, so on each of these machines, I installed Ubuntu. I created a user. I've got a root user named user, and I've got an application user named AdCirc user. And then I set up the networking, which is pretty easy out of the box with the Ubuntu base. And the network interfaces are a gigabit per second, although I'm not sure if I could benefit from having higher bandwidth, but that's something for me to look at because I haven't really run benchmarks. But if I were to start trying to hyper optimize AdCirc on these machines, I would be looking at getting like a 10. I don't know. They probably can support 10 gigabit per second, but I need to get a new switch. But the real way that HPC centers create high performance networking is by using what's called InfiniBand or MyraNet. These are cards that provide it's RDMA, remote direct memory access. And so OpenMPI can actually run and use these specialized network cards directly, which allow it to access memory directly on across the different machines. And it has like a more efficient protocol. I forget what the InfiniBand protocols is called. It might be InfiniBand, but it has a specialized protocol that is optimized for these scientific workloads that are using things like OpenMPI. And OpenMPI is aware and has drivers for using the InfiniBand protocol and using these RDMA network cards directly. So the benefit there is it's not they're not memory accesses that are managed by the operating system or the kernel. They just go straight to the memory, like in the most direct route possible. So in a real way, the operating systems and all these machines are not even aware that their memories are being, poked and peaked. Okay.
How does it perform compared to regular traditional memory?
It is a lot faster. I don't have any. I can't quantify that, but you're. It's
Why
a
is
more
it faster?
well. It's a faster. So it's faster, like gigabits per second. It's going. It's using a more efficient protocol in the network, and it's going directly. It's going hardware to hardware basically over the network versus having to get processed by the operating system, or even by I would assume like the TCP stack that's even in the operating system. It's just going straight. Like these cards can talk to one another, and then they have direct access to the memory on their host machines. So I would say that the speed up is significant, but I can't. There's probably benchmarks online, but you want to look like InfiniBand or MyraNet, I think is the other one. So. Oh, the other thing is when networking, as far as networking is concerned, it helps to have an external DHCP server. I mean, I'm not a networking expert, so that just made it easier for me. So, but you're going to have like fixed IP addresses because if they change, you're going to have a hard time because the compute nodes each compute node needs to know what the IP address is for each machine that's in the cluster. And then when you set up Slurm, it's going to have to know that. This is software installation. Now this is stuff specific for AdCirc. So I'm going to skip through that. And then one thing I would also recommend is Intel provides their latest compiler suite for free. Yes, it is a binary blob, but if you want to go for optimizing your cluster, it provides an HPC if you want to get the HPC distribution or pack or whatever they call it, but really all that means is it comes with OpenMPI, their implementation of OpenMPI, and it includes their C compiler, their C++ compiler, but the big thing, especially for HPC, is it includes a Fortran compiler, and that's the AdCirc's written in Fortran, so we need to use that. Overall, I don't have specific benchmarks to show, but my experience is an estimate is that the code compiled with Intel's compiler suite, AdCirc that is, runs between 20 and 30% faster than compiled with G-Fortran, and in particular G-Fortran 9. And so if you're going to be running any kind of Fortran codes and you're looking for performance, you're definitely going to want to use the Intel compiler. And it's free. You just don't get to see how they implement it. It's LLVM based, so they refer to the non-LLVM Intel compiler suite as Intel Classic. Now I don't know if that's an actual marketing term or that's just what people have started calling it. That's how you refer to it. But one API refers to the LLVM backend where they all, there's the front ends that parse the language and then create the LLVM IR, the intermediate representation, and then LLVM itself will take that regardless of the language. So you're talking about like having, one way to compile different languages. Well, that LLVM kind of provides
LLVM
that.
is a bytecode level. It's a low-level virtual machine. That's what LLVM stands for,
Right.
And it's something that can be used by static languages to share a low-level bytecode format.
This isn't something that I think Perl could use.
So it is something, but only underneath the compiler. It doesn't help the interpreter directly.
Right, so you would compile.
I will say this, that Raimi had a very interesting idea early on to try and use BC to emit non-optimized C code that represents the opt tree of Perl code and then take that C and the C of the interpreter and use Clang to compile them both into LLVM and combine them directly together and run broad optimizations on the LLVM that would optimize across both the interpreter and the application code. And the theory would be that you would receive untold optimizations because no one, it's experimental. I mean, no one knows what would happen if you did that.
Right.
And I know that he started working on it, I think it was part of P2, which was up in my previous talk.
That would be interesting.
But it never got
because my experience with BCC is it generates basically like hoisted C code that makes Perl runtime calls, like to the shared library, like libperl or something.
As far as I can say, it's C code that is the exact equivalent of the op tree it's essentially the bytecode. It's Perl's bytecode is called an op tree because it's not strictly bytecode. It's a weird thing that's more than just bytecode. But BC is a way of sort of
it gives you C code.
It gives you
it's not a translation of Perl to C, but it gives you
the op tree is C.
Okay.
So all it's doing is dumping the C of the op tree into an external file.
Gotcha.
That's all it's doing. There's no real translation that's happening because, again, like Perl is written in C, the interpreter is written in C, so all that op tree stuff is C. It's just a bunch of crazy C calls to all these macros, like all the Perl guts macros and all the unpublished macros that are not for user accessible purposes. All of that is, I think, what the op tree is. And so if you read it, it doesn't read like C because it's mostly calls to C macros,
right.
But it is technically still C in that you call the C compiler to compile it. So that's why BC emits the unoptimized, and BCC was supposed to be the optimized version that never really worked right, but BC is a useful thing in the sense that it's the way to emit the op tree.
Right.
That's what BC does, I guess.
And you can compile that with
C. Then you can do whatever with that. And there was nothing much ever super interesting that could ever be done with it other than cPanel compiling all their code to hide their source code from their customers so that they could distribute their code and it would start up faster.
That was the official reason.
That was the reason, but the
obfuscating it
was the real reason. And that was because apparently Nick Costin was the big genius that started cPanel, and he took Malcolm Beatty's broken code that hadn't been working for several major versions of Perl interpreter and got it working again so that he could release his cPanel code without the customers reading the source code. So no, I don't think that startup time was ever the initial purpose of doing that. That would just became the corporate mantra of why they were doing it.
I think there's several hundred megabytes of initialized memory.
Oh yeah, I'm not saying that it's not doing that. I'm saying that wasn't the main reason why he did it.
Right.
The main reason he did it was because he didn't ever want anyone to ever have a copy of his source code.
Right.
And there's no other way to do it. Because you have to then feed the op tree through a C compiler, and that C compiler, if you set -09 or whatever, you're never going to be able to reverse engineer the original op tree and then Perl out of that. I don't think really. Yeah,
it would be difficult.
It would be very, 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 very
You'd need to use
it would be an AI level thing or something.
Yeah, probably.
Anyway, so not to sidetrack you, but there you go.
That would be interesting. I still have yet to try to compile Perl with Open API, but I still want to for the Open MP stuff, which is different.
One API.
Yes, I want to see if I can compile Perl with one API so that I can try out my OpenMP stuff, which is separate than the OpenMPI stuff we're doing, which is not integrated. Well, there's some modules that integrate with Perl, but we're not doing that here. So many things. Okay.
So many things.
Okay.
They're all good though.
Yes, very, very interesting.
And confusingly, similarly named.
Yeah.
As well. OpenMP, OpenAPI, OneAPI, OpenMPI.
Yeah.
They're all different.
OpenAI.
OpenAI.
Okay, so we'll get back on to talking about networking very quickly. So you can imagine when you're running a parallel job across computing clusters, you can't stop, and you don't want to have to deal with passwords. So what you have to do is set up passwordless SSH authentication from all machines to all machines, and that's why you should have like static, non-changing, or statically assigned. I find statically assigned DHCP IP addresses, and to be the best way to manage that. And once you have those set up, then you can set up the like the etc host file and then the SSH config file, so that you can use short names like compute 01, compute 02, compute 03. There's probably a better way to do that. I'm definitely not a networking expert, but that for me, that was the most expedient. So that's one big clue or hint there, is you need to make sure you have the passwordless authentication set up. And OpenMPI does tunnel SSH across all the machines to communicate. All right, so that is SSH is a critical part of running these MPI jobs. I think maybe back in the day you could use RSH, but we're not in those days anymore. Okay, so we'll talk about NFS here.
RSH was
a very long time ago. Okay, so I thought I was going to be fancy and try and get away from having to have a shared mount, NFS mount across on the cluster, but it turned out to be much more of a pain in the butt to get around that. So I broke down and realized that setting up NFS is actually very simple. Tuning it, on the other hand, takes a little more time, but I figured that out eventually. But you want to have a shared workspace that all of the machines can reach, and that's where you're basically going to run your jobs in. You want AdCirc is probably very typical of HPC applications, where it wants to, if you start it up in a directory with the input files, when it parallelizes it, all the other processes want to be in that same directory path with access to the same input files. Okay, so you're dealing with not only the program, the multiple processes communicating the program state across the cluster, but also having a single or unified view of the file path in which you're working. And so the only, or I guess the best way to do that is NFS. And I say it's the best way to do it because the clusters at University of Texas use it. The clusters at LSU use it, and it's pretty much
standard.
It's the standard.
It's the standard. I mean, why fix it if it's not broken?
I will say they've got specialized file systems that enhance NFS.
Oh yeah, NFS is the bare minimum.
NFS sits on top of their, like Luster FS is I think the most common one. So that's a high performance.
There's probably a half dozen different variations of NFS like things.
Yeah, so it's like I guess a standard.
There's one called Alvin FS that I had to use at one point when I maxed out NFS's capabilities, and it was because I had an NFS server with a whole bunch of Windows clients. Can you believe that? I allowed that to happen one time. I should have never done that, but I was working on a bunch of Windows systems, and of course the server's Linux, and they had thousands of directories stored inside of one directory. So every time someone tried to just open that up in their Windows to look at it, it would like grind down the server. And so first of all, you shouldn't put that many things in any one directory. So we kind of fixed that by alphabetizing it. But secondly, it was still going slow. And when we upgraded to Alvin FS, it started going super fast.
That's good.
So it
I'll have
is
to look into that.
it uses some kind of special caching, communications, compression, something like it's an NFS replacement or a higher powered version of it.
I'll have to look into that. That would be interesting.
It is worth looking into if you're doing this sort of thing. Yeah.
Awesome. Well, I did have to go through some tuning, which I will talk about, I guess, in a bonus slide later. So one thing I wanted to say about NFS is not only did I find it beneficial or necessary actually to set up a scratch space that all the clusters could use as the work area for the program for AdCirc, but it was also beneficial to set up an NFS mounted home directory across all of these machines for the user or users that are running, that are going to be running across a cluster. And the reason is that it greatly eases the distribution of keys and setting up of the passwordless authentication. So really,
Yes.
you just have to modify, you create your key pair, and then you in place in your home, you modify the .ssh authorized host file. And if you're on a NFS mounted home that is shared with all of the machines, you're set up. Like you can, it just uses the same two files. So
I believe that is a standard practice in many.
And I rediscovered it.
In many Beowulf clusters.
I rediscovered it kicking and screaming because I didn't want to have to do it, but I did it, and it's a good setup. I recommend it. Okie dokie. So ASGS is the program or the Perl-based program that or Perl glued together and Perl heavy program that we use to run our storm surge forecasting system. And that's just covering that. Here again, I talked about it last year in the science track at the Perl conference in Vegas. So please refer to that. I recommend it. And I also recommend all the other science talks we've done at that conference. Okay, now say that's all set up and you've compiled AdCirc or whatever program you want to run. In order to start up your program, now you program, and I don't show any MPI code here, but in order to use MPI, your program has to have MPI calls in it, okay? And
it also has to be called by MPI run, doesn't it?
Yes, and that's actually what I'm talking about now is MPI run and MPI exec are the same. They're the same executable.
Oh, really?
I grew up calling MPI run.
Oh, so what is it, a symlink or something?
I don't know, but they do the same exact thing. But I think MPI run is what. So the initial implementation of MPI was called mpitch.
Yeah.
And then there was mbupitch, and then those used MPI run. And then there was mbupitch 2, and then there's OpenMPI. And OpenMPI, I think, is when they came up with MPI exec.
Oh.
I could be wrong, but I just remember back in the day, and we're talking more than 20 years ago now, starting up an MPI job, I would use MPI run.
Correct.
So there you go. So if you're the only person running on this cluster and you just want to test that your program works and you know it's MPI implemented or MPI enabled and all of that, you can use MPI exec, okay? And MPI exec requires you to set up a host file. So the host file is basically just, it's a file that MPI exec uses to map host names in your cluster to the number of CPUs or cores that are available. And then MPI exec will distribute or will spawn, it'll SSH into the host and then spawn for however many, how many processes you specified, one of these commands. And it just takes one command. So for example, if you were to run MPI exec -np, I don't know, 32, and then you gave it the host file, and then you ran hostname, it's going to run hostname 32 times across the machines that are listed in your host file. So that's how it distributes the job.
Hostname being a Unix command that simply tells you the name of the computer that you're on, right?
Correct.
It's a test command. It doesn't actually do anything real.
Right, exactly. So this slide talks about the host file, using the host file with MPI exec, and that text file looking thing in the box there. That is what it looks like. At least that's the IMVA pitch format, which oddly enough, Intel's OpenMPI implementation uses. The OpenMPI format is different, but it's just host name, colon, and then max number of processors you want MPI to utilize. You could have a lower number than what's available. You could have a higher number than what's available. That's basically how it's going to fill up or satisfy your requirement of how many processes you want to run. And at the very bottom of this slide here, MPI exec dash host file and host file.txt. That host file is this one right here. What's in the box, compute 01, 02, 03, 04. And then -np is, or --np is saying how many processes you want to run. PadCirc is the parallel version of AdCirc. And then -w1 is actually that's not an MPI exec flag. That's a PadCirc flag, so you can ignore that.
So MPI exec knows to ignore
MPI
after
it basically just takes anything after a recognized flag as the executable command. Okay, we can skip this. I added some support for a local cluster without a queue system to ASGS, and that's just talking about this. Basically, you can just specify a host file rather than that you're using Slurm, which ASGS supports out of the box. Okay, I'm going to talk about some bonus slides. Let's see. Okay, that's hostname stuff. That's the hostname. Oh, hostname configuration. So I'm just talking about Etsy host. So what I did to set up networking was I named everything. Everything had a short name, so like compute 01, 02, 03. And then I used DHCP to assign an IP address, and then I set it up in what was it? It was like a access point or something. I was using a router to make sure that those computers got the same IP address each time, and then that gave me some stability, and I was able to set up Etsy hosts on each machine, and then the SSH config on each machine. That's one of the things that I don't have rectified. Another thing I don't have rectified is setting up NFS.
Okay.
But I do want to do that because part of what I do is setting up clusters for clients, and I would like to have an easy way to just set them up. So put them together, get the networking set up, and then run a Rex script, a Rex file, they call them, and just have everything get set up, which would be cool.
I would love to be able to do that someday.
Okay, that talks about setting up batch access, but I think we've talked enough about that. SSH config. If anybody's not aware of SSH config file, and I wasn't aware of it for many years, so it's worth pointing out. You can set up a file in .ssh directory of your home directory called config, and in it you can define a bunch of things. But the coolest thing that you can do is you can set up basically aliases for remote hosts, and then you can have more than one. You can have more than one alias for the same remote host, but it allows you to specify all the SSH flags that maybe you would specify otherwise in a very long and nasty looking SSH command. So the one here, it's just specifying compute 01, host name. Actually, I think I removed that. You can remove this right here. That's unnecessary. But username, you can user port. Okay, it can be a non-standard port. These things I have set in there because it was for one reason or another. I think we were having issues with one of the connections timing out with a server that we were actually uploading data to, and so that's kind of irrelevant to keep alive. The strict host key checking, we set that to no because we found in operations, we found some of the machines like to change their keys, and we don't really care about security, I guess, when we're running operationally and on a controlled supercomputer. So we just ignore that. Like if the host key, we just say don't check the host basically, and because it was stopping things. It was like we were in the middle of a storm. Well, it might not be. It might not be like during. Might be on startup. So like say, if it was like a few days or a week or something between starting up the system, they may have changed keys on the different compute nodes.
I thought that the keys were supposed to be relatively stable things.
Wait, I'm confusing things. This has to do more with this doesn't have to do with the cluster. I'm sorry. This has to do with machines. Sorry, I'm confused. This has to do with machines that we are sending data to.
Oh yeah, that could definitely change.
Those we have found that those will change on us sometimes because they're just maintaining like storage servers basically. So they're just doing whatever they want to do. Okay, and then this identity, no, not identity. Identity file is important because you can specify a non-standard key path. And then now what's interesting I wanted to point out is control master, control path, and control persist. We had to set that up because one of the machines that we were sending data to was we were sending data frequently enough to trigger their firewall, and they weren't going to give us an exception. So what those three lines do is it sets up a persistent SSH.
The keep alive thing.
It's a local keep alive thing. It keeps your SSH connection alive, and it's basically specified with that .ssh mux, and then the %H, %P, %R. That just gives
some serialization.
Yes, that's some printf type stuff. So this just tells SSH like start up the connection and then don't kill it when it's done, and then it persists. It like creates a pool of SSH connections. And so the next time that you need it, based on however that .ssh, we'll call it a cookie or a session file, is specified, it knows which process to reuse. And so to the remote server, it's not a new session. So the firewall was no longer, we did that, and the firewall was no longer triggering on us and blocking us, which was nice. Okay, moving along. That's just I guess a decent sized SSH config file, but we've got.
You're gonna have to zoom.
It's not worth it. It's just a bunch of. It's like a bunch of.
Like go into presentation mode or something.
Well, it wasn't showing up. It wasn't showing up when I was sharing.
Oh, was it?
I think I'd have to share my whole desktop or something. But anyway, just maybe what I can do is.
Just do full screen.
Is that better?
Yeah, that's better. Thank you.
Okay, so basically, I have duplicated entries for each host, and yeah. So you want to have an entry for each of the machines on your own personal cluster.
Okay.
If you're not, now we haven't even talked about setting up Slurm. I don't have slides on Slurm, but
what is Slurm?
Slurm, I will get to. I want to get to the NFS. All right, NFS client server setup. So the left-hand column here, that's just some like how you set it up. Like you have one server, NFS server, that's physically connected to the disk you're sharing, and then on the right-hand side you've got the client. So you'll see that I have this line here. These attributes are set up so that the NFS it is actually performant. So it was just being dog slow, and I had to figure out, okay, what do I need to do to basically make this NFS mount suitable for heavy reads and writes. And so this is what I ended up coming up with. And I mean, the names are what they are. I would just, I don't know what no root squash is, for example, but the other ones you can kind of tell. And there's no updating of like the access time or anything like that. So that provides a little bit of optimization. So the point here is that if you're going to be doing like HPC type workloads on an NFS mount, you're going to have to tune it, because the way it comes out of the box is definitely not suitable. You're gonna definitely hit some performance issues.
No root squash is an administrative security feature in NFS that prevents unauthorized root level access to the NFS server by client machines.
Okay.
It protects data from being manipulated by untrusted. So I guess this basically turns off the security checks.
Yeah.
No root squash means don't do security checks.
Yeah, sounds like it.
And thus goes faster?
Yes. Now, I mean, it's the
because it's all trusted data. These are all machines that you
like
run.
that's
you
why
control.
I said I don't care. Like, we're not worried about security. We're within a cocoon anyway, so we're not.
You're
just
not worried about security inside the cluster.
Correct. We treat it as a trusted environment.
We do clear about security in general.
Yeah, like we can't just people aren't able to hack into the machine. And like the local cluster, hopefully you don't have, it open to the internet. So
correct.
That's the other part. Okay, NFS tab on an NFS client. This is what it looks like. I think this is what I ended up with. But anyway, just like you would mount, local disk, you'd have an entry in FS tab. That's the FS tab. Tuning, talked about. Yeah, I mean, ChatGPT came and helped me out again, but it was helpful for summarizing the information and trying things. No shame there.
There's no shame in having an AI help you configure stupid operating system crap.
Exactly.
Because it's just a headache, and those of us that have spent our entire lives doing it are ready to never do it again.
Exactly.
I'm just saying.
But I do recommend.
How do you think my beard got so long and all of his hair fell out?
I mean,
okay, it all went from over there and it stuck up under here.
I do recommend you going through some pain, but
well, you need to understand what you're doing. You can't just let the AI tell you do this. You have to say why and what does it do.
Exactly.
Like him copying the no root squash without having any idea what it does. I mean,
I think at that point I was just like, whatever.
Yeah. Yeah, squash, zucchini, cucumber, whatever. It's all the
pumpkin.
Pumpkins.
Pumpkin NFS. Okay, so this is just talking about NFS in home, installing Intel One API. It's free, like I said. There was a script I downloaded, but it seems to change from release to release somewhat. This is just ASGS stuff, AdCirc stuff. Okay, installing Slurm. Slurm is good if you have multiple users on the cluster.
What is Slurm?
Okay, Slurm is you know how like in the olden days in the mainframes you had to submit your jobs. It was a time sharing system. Mm-hmm. It's the same thing. Here you're like people want to use the whole cluster. It's essentially a big mainframe that you have to submit. You need to submit your jobs to if it's a shared resource. And so like
it's a queuing system?
It's a queuing system.
Okay.
And what you submit is a queue script, which is really just a bash script or a shell, some kind of executable. And it has some, you have to set like account information. I'll show you an example here shortly. How am I doing on time?
You're good.
Okay. So installing Slurm is a good idea. Not only is it a good idea if you have multiple users, but it's a good idea if you're the only user, I've come to find, because you might want to prepare and submit multiple jobs and not have to wait, and then just have them run one after the other as soon as the resources free up. So it is efficient for an individual who has multiple compute jobs to run to submit it and either just submit it and forget it and come back or be notified when they're done. Or you might be submitting a bunch of jobs that each one doesn't take up the whole machine. the queuing system will run them as many as possible, you know, at the same time. So it's also for your own efficiency. It's like it gives you work efficiency.
Yes, queuing
individual
systems have several different use cases.
Yes. And so I was again hesitant to do more work and install Slurm on my cluster, but at the end of the day, I decided just to bite the bullet. And I had been promising, who's the Rex maintainer? Frankie.
Ferky. Yeah, Ferenc.
Well, okay,
Frank is like Frank. It's like the name Frank, but it's Ferenc.
Ferenc. Okay,
yes,
I gotcha. Well, we
Ferenc Erky, or Ferky as he's called.
So 6 or 9 months
Frank,
ago.
His name's Frank Erky.
Okay. 6 or 9 months ago, I contacted him because I wanted to see if he was interested in submitting something to the Science Perl Journal. And it turned out, you know, he's a busy guy. He developed Rex to run his own consulting business. Okay, so he uses Rex as part of his own job, and he's got clients where he does automation, DevOps automation, and he also runs the open source project. So I said, you know what? I do have a use for Rex. I'm going to be needing to set up a Beowulf cluster at some point. I will use Rex to do this, and I will, you know, either give a presentation or, you know, write some kind of short paper on setting up a Beowulf cluster using Rex. And so that's why we're here today, because I actually was good with, you know, good to my word and have done that.
Well, and also I think that ultimately this could be an extremely useful thing.
Yeah. So
right? I mean, like having an automated Perl clustering system is something that like I would have a need for, and
yes.
I think many other people would potentially as well.
And I've got a large chunk of it done.
I mean, this could be shopped around to a whole bunch of HPC shops and universities that may be
a lot of those
of a control system.
A lot of those folks use Perl. I mean,
yeah, you know, well, they're all.
I mean, the admins at University of Texas, their HPC center, they're old Perl people. I mean, not exclusively, but they a lot of their tools on their system. Do you use their HPC? Your University of Texas?
Have you used the high performance computing or supercomputers at UT before?
Like the SSH.
Yeah. Yes, they're remote access machines. Yep.
Okay. So a lot of the tools that they have on there are written in Perl.
I don't know what the machines' names are. Aren't they called like Ranger or?
Ranger is it's Lone Star 6.
Lone Star, yeah.
Stampede 3. And then they've got some visualization, GPU, AI machines, storage machines. But it's a world-class facility. It's pretty awesome.
I've been there.
Okay, so I forgot where I was going with this, but
Slurm.
Oh yeah, so Slurm is a queuing system, so you can submit jobs, and it was very easy to set up, and it was. Oh, I was going to talk about Frank.
Yeah, Frank Erky.
Frank Erky, super nice guy, very helpful, very supportive of his project, yeah, I really enjoyed working with it. If you've ever worked with like Puppet or Chef, it's like that, but Perl. So
we definitely want to tell people that are using Puppet or Chef that they should consider Rex, or people that need a control system to consider it instead of Puppet or Chef.
Yes. And let me take a step back real quick. One thing I want to point out.
Rex is one of the real Perl programs that's really out there that has a real solid, unmistakable value to it.
Yes, it's something that we should all be trying to use.
I mean, there's not like hundreds of these things, right? There's a few big ones, and that's one of the real ones that's out there still being used and important.
Before I get back on Rex, I want to mention there are devices, if you want to spend extra money, these network attached storage systems that are highly performant, and they do support NFS. So if you want to if you aren't like just trying to do the cheapest possible option, and you had a budget, then it's probably a good idea to look at one of these NAS. I mean, you could get a tremendous amount of storage. I think I saw not too long ago they were coming out with 100 terabyte drives. I mean, this is being driven by AI data, the data load. So, but we can benefit.
How big are they? Are they
100 terabytes?
I mean, physically.
I think it's a standard 3.5 inch format.
Form factor.
Yeah. These are just a list of them. I don't think I didn't add prices, but they're like between $1,000 and $2,000. I didn't buy any of these, but I would love to, but I didn't. And then for accessing the cluster outside of, so I have my cluster running at my home. It's on the local area network, and I'm going to access it here in a second. But I'm accessing it through Tailscale, which I really have enjoyed using.
I haven't heard that before.
It basically allows you to put together your own VPN, so that it gives you access to like your machines inside. And it's got.
Is it a Linux software or?
It's Linux. It's a Linux client that runs on, but it's a commercial product, so it's.
Oh, really?
But there's a premium tier, and then you install it, like, and it supports all the operating systems. But you install it, and then you put in your credentials or whatever. Or no, it gives you like a a token code or something. You have to register on their site, and then it adds it to your virtual VPN, and then you can. And
so does the VPN pass through someone else's servers?
I'm not sure how it works. I think they use WireGuard underneath. I think it's all end-to-end encrypted. I mean, I don't know how you would verify that, but a lot of people use it. I found it very useful.
Okay.
For this. I know
it's an off-the-shelf VPN solution.
Yeah, it's worked out pretty well. And so
does it touch Perl in any way, or does it not need to?
No, I don't. I think it's
because it's really just on the networking layer, so it doesn't.
Yeah, I think the clients are written in Go. I think I remember reading.
But again, even those clients don't need to interact directly with Perl because they're just on the OS networking layer.
Correct.
And they don't actually need.
So this isn't being used as part of the HPC cluster. Although you could probably set up a Beowulf cluster using it, it'd be probably pretty slow.
Imagine a Beowulf cluster of those.
Exactly.
I think that ultimately someone made a Beowulf cluster, and then someone said, "Imagine a Beowulf cluster of Beowulf clusters." So.
Exactly.
And that's how the internet was.
We're bringing up the moms from the 90s.
Yes.
Most of these people kind of have no idea what's going on.
Well, they need to learn. All right,
moving on. Oh, that's just me advertising. Okay, am I still sharing? Okay, exit full screen. Okay, I'm going to stop sharing that, and then I'm going to share. I'm going to share my terminal. That is it. Okay, can we see?
Yes.
Yeah, it's okay.
And it is barely readable, so that's actually not too bad.
Okay, I will.
I mean, can you read that? Kind of, barely. Yeah.
Okay, well.
That's a little better. You zoomed it a little bit.
I will jump. Let me get rid of that red stuff here. This is the reps file. I'll make this one bigger.
There you go. That's,
okay.
Yeah, that's better.
So this is a.
Back down. There you go.
Okay.
You have to mute yourself.
I have to mute myself.
No.
Oh. Okay, so this is a Rex file. So I don't know I forget what they call them in Puppet file, or But this is let me do this. Okay, so this is colored syntax highlighted.
Thank you.
As if it's Perl, because it is Perl. And so you'll recognize the use Rex, and then it's got the dash feature.
So this is sort of the Rex domain-specific language encoded into Perl.
Exactly.
Okay.
Yes.
Because group, user, pseudo password, desk task,
These are all
package, none of these are Perl built-in commands.
right. This comes in from the dash feature.
They're all taken in by Rex.
It's got a feature bundle. This exec auto die is just something that I was recommended that I use, because otherwise it'll just kind of blow through everything even if there was an error.
Right.
And so I've got basically to define the host groups. Head node, compute 01 is the head, is the main one, the login node. It's also a compute node. The workers, actually, I don't use this this group, but I want to be clear that all of the computers participate in the computation. And then all nodes is all nodes. I could probably get rid of that workers, but so user, pseudo password, these are things that are, they're functions that are provided as keywords by the Rex module. And then here's where you describe it by task, and then there's a description, and then task, you name it. So this one's called setup slurm, and then what group, it means which set of compute nodes do you want to iterate over and run this on. And so
And those are the ones that are described with the group keyword above there.
exactly. And so I will just give an overview. There are a lot of things about Rex I haven't tried or run into, but I can give everybody an idea of what's going on here. So you can consider, host name here, that's just the Rex way to get the server name that it's currently on. So implicitly, you can imagine that this code, it's kind of like, I guess, a fork, where you can imagine the code in this task is getting run on all of the remote machines that you've specified. And so the first thing that this task is doing is getting the host name through a function called connection-server or connection-server. And then there's just a check here that is this the head node, and it's the head node if it's compute 01. Okay, so there's some things in here that I run if it's the head node or not, because the head node, the way that Slurm is set up, the head node runs the main Slurm controller and then a Slurm client, and then all the other machines run just a Slurm client. Okay, and they also run a secondary service called Munge, which provides authentication for Slurm across the whole cluster. So like the authentication that we set up, that I talked about setting up before, that's not used directly, or is it? Actually, I don't know if it is or not, but I do know that Munge itself is used for the nodes, for the Slurm client on all the nodes to communicate with the Slurm controller. That's how that works. Don't ask me to get more detailed because I don't know.
You already lost me.
Okay, so the say run uname-a. Say is the say keyword, like the Perl keyword, and then run.
Say is the same thing as just print some text out.
Right. That.
With a new line at
right.
the end.
But it's the one provided by the Perl interpreter.
So
and then
say
run
is a print. Say is a real Perl.
Correct.
Say Perl 510.
Yes. And so run is a Rex thing, and it's got in quotes uname-a. So run will take that and just run it as a system command. It'll shell up.
Uname is yet another test command in Unix style operating systems that
Correct.
doesn't really do anything. It just prints out some information about the kernel.
Correct. Now, Slurm, so now on all of the machines I'm using.
And I think that's actually kind of like a a mu from micro name. I think it was like microkernel
Oh, interesting.
name.
Okay. I never knew why it was
Yeah,
called.
I don't think it's really a U. I don't know. I could be wrong about that. But
U name.
yeah.
PKG is a way that Rex provides management of installation of packages. So I haven't dug into this, but it supports multiple distros. Okay, I don't know how it handles Windows or if it does, but like this is Ubuntu based, so it's going to be doing apt-get or whatever. If it was like Red Hat or CentOS, it would be using Yum. But here I'm specifying PKG, and then the package I want to install on all the machines, there's a slurm-wlm, and we just want to ensure that it's present. So this is a declarative way of saying install, make sure this package is present. And then
that's
just
definitely a special syntax that is not part of regular Perl.
And the whole, like, if you've ever used these DevOps orchestration languages, you know that they're very declarative, or like the goal is to make them declarative. Like
it's basically
you
like
state
a type
what
of configuration file.
right.
Kind of.
You describe what you want the machine to look like, or to have set up, and then the languages do all the dirty details that you otherwise would have had to like program in. Imperatively. So,
and by the way, it's a Unix name.
Oh, okay.
Unix kernel names.
So Slurm WLM is the Slurm package. It's a Slurm client. All compute nodes get that. Munge is the authentication client that Slurm uses. All computers get this. Now, if it's the head node, that's the Slurm controller. I just want to jump down here. Oh wait, so Slurm. Okay, that's the single Slurm package. But I want to point out, if it's the head node, here it's generating the munge key, so I have to just directly run this command on the head node only. And then here I have to do some funky orchestration to get it over, to copy this key to the compute nodes. And so there wasn't a real clean way that was obvious to me to do this, but I also think that munge is like not overly restrictive, but it was because it's a key. It was very picky about the permissions and the ownership of the key. So I had to kind of jump around.
It has automated security restrictions.
But Rex has this really nice declarative way of saying, I want to get this file onto this machine.
Oh yeah, I mean clearly this is pretty straightforward compared to other systems.
And this CP here, this is doing a local copy, okay? So on the head node only, but not where you're running Rex from. So you run Rex from one machine, and then it kind of, it octopuses all over the place and does its thing. Now the file, this is a nice declarative way versus CP, which is imperative, like you're telling it what to do. File just describes the end state, and it just does it. The Rex ensures it happens, or at least it complains loudly if it not. And then it also has, the file directive also has support for directory. So here I'm basically just making sure that these directories are present on all of the machines, and that they are, ensure directory versus ensure present. And then owner is going to be Slurm, group's going to be Slurm, and then mode's going to be 750. One important note about Rex, and this is stressed to me, was that the modes, like the file modes and directory modes, you need to put them in quotes.
Also known as permissions.
Permissions. You need to put them in quotes.
Otherwise
it'll be interpreted as an octal, I guess, and then converted to an integer.
Instead of
probably not what you want.
This is like a bit encoded string or something, because it's actually the individual bits of these integers that are used to set the permission bits.
Right.
Like it's not the number 7, but it's 111.
Oh, on the
4,
permission,
2, 1.
correct, yes,
And that's the read, write, execute for the owner.
right.
And it's not 5, but it's 101, which is read, execute, or whatever.
Yes,
that translates to for
Yeah,
the
read,
root
write, and
ownership.
execute.
So, and then 0 means no permissions for anyone else.
Correct.
And the leading 0 is the special bits, which is the sticky or symlink or other related.
Right, exactly. Yes, something like that.
So it's not actually the integer 0750 at all.
Correct. This run pkill munge, that was me being pretty violent against whatever any running service. I'm sure there's a better way to do this, but this is what I ended up with to get my cluster running. I do want to get it refined after.
Why are you trying to kill Munge again?
Because I just wanted to make sure it got started. I wanted every time I run this, and this is just me.
You're killing it before you restart it.
What I wanted to do was every time it runs, it generates a new key on the head node, copies it over. So basically, you rotate the key every time you run this. You're rotating the munge key, and so I didn't spend enough time or ask any questions on how do I forcibly restart a service, and that's really what I want here. But so my solution was just to kill it. I'm sure there's a much more elegant solution, but and then you see the munge key has to be change modded over to 400, which means only the owner can. Only the owner has access to it, and only they can read it. They can only read it. Of course, they can change it back, but anyway, so I think that might be a dupe. I don't know why I have the second pkill munge. That's probably unnecessary. Unnecessary process murder. And then Slurm. Now Slurm, the Slurm CTLD control daemon, it's only running on the head node, okay? But I do want it running on. I want the client running. So let me jump down to this block. Now we're still in this one giant task, okay? And so on all the other machines, I want to make sure that this munge key is absent. So this deletes anything that's in there in Etsy munge key. And then I make sure that it's present. And I made this available. So source. So when you're using the file directive, this first string here, this first file path here, that's the file on the remote server. The source is specifying a file on the local server. So I have created a munge key locally, and I put it in a special place. And then with more permissions, so that it can just copy it over. And so it's getting copied over from there. So this is the newest key getting copied over to the remote machine in Etsy munge. And then do I set? Well, I'm setting it as 644, which is standard. Like, this is my file and anybody can read it. Setting up the Slurm configuration file. Okay, and that's actually getting pulled out of locally. So I have that locally here. Okay, all machines get the same copy of the Slurm conf, which is nice. So that gets copied over to the client or the compute nodes. And then here I just iterate over these directories and make sure they exist. Again, I probably can. I need to make this code tighter, but anyway, so that's all the files set up. It's installing the packages. It's putting the keys in the right place on all the machines. You generate the key on the main compute, the Slurm controller, which is compute 01 here, and then you make sure that key is copied over to all the other machines, and then you make sure that the Slurm configuration is copied over to all the machines and exists on the local machine also. On the local machine, you start up the Slurm controller, only. I mean, you only start that up on the compute on the controller machine, but on all the machines, including the controller machine or whatever machines are participating in the computations, you're going to start up what's called slurmd. Slurmd runs on all the machines, communicates with the controller, which is only running on one machine, and then that's it. And so and then I have a task here. It's just called query time. And this is just kind of like a sanity check. I also have a rec script that is used to install Crony or Cronny, I don't know how you say it, which is a daemon that synchronizes time on a cluster across all the computers. So it's literally exactly what I was going over before.
Timestamps to all matching logs and stuff like that.
Yeah, and there's it's just you want everything as tight as possible.
You gotta be careful though. If you're using it for timestamps, you can't necessarily, depending on how often you run it may not be millisecond accurate.
It won't be. Yeah.
You cannot use it for millisecond accuracy log.
Well, in this case, Slurm is using it. I mean, it's just I'm not sure if Slurm even requires it, but I think it's probably just recommended. However, it's being used. I think that the time granularity is sufficient. So,
for your purposes, yes.
For these purposes, it is. And so for the Cronny, really, I just make sure that it's installed on all the machines. That's what this package Cronny is, and then I copy over. I have two different files. One that gets copied over if it's the head node. One that gets copied over if it's a compute node, and then I guess the main, the head node's taken as the main source of truth for the correct time. And so again, there's a declarative file. I think that this file construct or whatever, that's probably going to be a very frequently used, directive or whatever.
Infrequently or frequently?
Very frequently.
Very frequently.
Yeah, I can see it coming up. Because what are you doing? Like when you're orchestrating stuff, you're like installing things, and then you're putting in configuration files in place, and that's probably like a lot of what 80% of what you're going to be doing anyway. And it's no different.
File manipulation.
Yeah, that's no different than that's exactly what I need here. So all in all, and again, I've had experience with Puppet, Chef, and Terraform. I would definitely say Rex is more than on par with that stuff. Plus, it's Perl, which gives it extra points.
Oh yeah.
My final thing I will close with is I think that in order to get the most out of Rex, you really need to be familiar with Perl. Like, I think that you can probably pick it up as just a generic, like, orchestration or DevOps, what do they call it, deployment type language, but it is less neutral. It is decidedly Perlish, more so than like Python or whatever the other ones are, whatever their implementation. Yeah, so but that's good. That's good if you know Perl. Like for us, I will definitely use Rex for things. But if you're coming at it as you're looking at it, you're not familiar with Perl, and you're looking for another language, it's probably not going to be. You may be okay trying it, but I guess your mile may vary.
Well, people that haven't used any of them before, they don't know or care. So
they may not. They may not. But I guess it's more like if you are familiar with Perl, I would absolutely recommend. And you have to do this kind of stuff. Absolutely.
Somebody that's already doing Python only is probably already using Chef anyway.
Right.
So
yeah.
So
but if you're
they're not really our target audience.
If you are using Perl and you have a choice, I would definitely give Rex a shot, and even force yourself to use it, because your ability to use Perl is going to make you a very efficient or proficient Rex user very quickly. and it does the same basic stuff. Yeah. So good job.
I got a question.
Yeah.
One of the things about a tool like Chef, which is commonly used, or Ansible, which is another one that's commonly used,
Mhm.
the commands are assertions that are idempotent. In other words, you can run them over and over and over again. And the first time you run create the user, it'll actually create the user. But the second time you run it, all it will do is it will make sure that the user is set up the way you want. So if the user's already there, it'll make sure that it's got the properties that you want. And if it doesn't have the properties you want, it'll adjust it to fit it. But it won't rerun the create the user command.
Right.
Is rec similar to that?
Yes.
And then it's idempotent. You can run over and over again.
Not having dug very deeply into it, from what I've seen, yes, because
Because that's sort of like one of the claims of fame of a system like Chef is that it's like you just run it as much as you want. You don't
Yeah.
have to, like compared to like the old school, like you might have a setup script for your box.
right.
The admin knows run this script once and they set up the box, and then after that
You can't run it
everything's kind of
again.
loosey-goosey. You can't rerun it.
Well,
and blow the
I will-
box up.
So I want to say that it is easy to create a idempotent script that allows you
Okay.
to do that. And now I don't know how implicit it is because I don't have the experience,
Okay.
but I think it is not hard to
But
get
it's
to.
intended that's sort of the intent.
Yes, and I think that's probably a quality you want with any kind of DevOps
Exactly.
type of thing. But I'm going to run this. I can rerun. Now, I'm running the Slurm setup, and all it's really doing is rotating the munge key. Now,
When
when
you called pkill munge multiple times, well, I guess that was a different kind of case. You didn't really purposely call anything other than the pkill multiple times.
right.
Okay.
Oh, and I'll show you. Okay, so while the previous talk was going on, I lost power at my house. So 2 out of the 3 machines came back
Oh
up,
no.
and so that's why That's why
That
we're
never
getting.
happens in Texas.
Yeah, it never happens, especially in Houston. And so I got an email from Centerpoint or from Constellation. They said, you have an energy or a electricity event. And I'm like, I'm still connected to my cluster. And then all of a sudden, I guess
You ain't.
the batteries ran out because I've got UPSs on them,
Okay.
but they don't last very long, as you can imagine. And they were cranking away on a ad circ run across all like an 84 processor job.
Wow.
And so anyway, that's why it's not coming up. But you can see Compute 01 and Compute 03 are coming up. And then I actually had, let's see if I accidentally killed my job. But I don't think it would have. Okay, so I restarted my AdSearch job, but it's only running across the 2 compute nodes. But this is just this is Compute 01. It's just HTOP showing that it's running. And then I can SSH into Compute 03 and then run HTOP again. And it's running.
HTOP is
like a better
graphical version of top, which is a program that shows which itself is like a sorted, repeated version of PS. It shows all of the processes running, but sorted by those taking the most processor or other.
I don't ever use if HTOP's available where I can install
HTOP, the main reason it's different is because it shows all of these processor cores with their little graphics bars across the top, and that's not shown in regular. And the memory and swap bars.
Yeah, you can see that. So load average is 28. Well, there's 28, processes running. Another cores, one final thing I will mention about Slurm is that Slurm understands how to pin processes to the CPUs, and so it's in that way it's better than just running MPI exec, because you'd have to look up the options to tell MPI exec, okay, pin these processes, whatever CPU core they start on, make sure they don't move. And so you can MPI tell the MPI exec to do that, but Slurm knows MPI exec. So, you know, it
Okay.
is fully integrated with it so it can be as efficient as possible. And so I realized that that's another benefit. Once I installed Slurm and started running it, I realized that that was a benefit.
Okay, so Slurm is well integrated.
Slurm also allows you, yeah, if you want to run as efficiently as possible on your cluster, like at runtime, I would install Slurm also. So, and I think that's it. So.
Okay, well, thank you, Brett Estrade. And let's have our round of applause for Brett.